Good morning to all. Hope you all are fine. And today we can start our lesson. And today we are taking the continuation part of our previous class. Did you remember our previous class? That means in that class we learned about the ancient peoples, how they are measuring the time, and we learned about simple pendulum, periodic motion, and the terms related to simple pendulum like length, amplitude, extreme position, and frequency, time period. All those things we learned, right? Did you remember all these things like definitions? All the terms definition also we learned in the previous class, right? And now we are going to discuss about detailing about the time period of an pendulum. We already know that what is time period, right? What is time period? Time period is the time taken by the bob to complete one oscillation. Then what is oscillation? Oscillation is the to and fro motion of an pendulum is considered as oscillation, right? So now our main topic, or mainly we are discussing about the time period of a simple pendulum. Okay, how can we calculate the time period of a simple pendulum? I told you that for this motion, oscillation of a simple pendulum, the time for only one oscillation is considered as the time period of the pendulum. So this oscillation, the last class I show you that how the simple pendulum movement, and for one oscillation it takes less than 1 second or like decimal numbers 1.2 seconds like that. But while looking to a stopwatch, we can't able to find out its correct one measurement. So what we will do, we will count 20 or 10 oscillation. Okay, then only we are finding the time period. Okay, normally we are doing this experiment by counting 20 oscillations with the help of an stopwatch. When we release the bob, at the same time we start the stopwatch. Then we count oscillation 1, 2, 3, 4 like that, and until 20 oscillation. Maybe we can take 10 oscillation also. If we are taking 10 oscillation, then after 10 oscillation maybe that stopwatch reads like 30 seconds. Then this 30 divided by 10, like that we can do. Okay, if we are that 30 seconds for 10 oscillation, then one oscillation 30 divided by 10, like that we can measure, and that we will explain more. We have some kind of problems has to solve in the same basis. Anyhow, we can go to about time period and the terms related to time period. We already knows that when we consider about a simple pendulum, it's contain a string and a bob. While this movement of a simple pendulum, what are the factors? Like we are only consider about the time period of a pendulum. Time period we knows that the time taken for one oscillation. Okay, time for one oscillation is considered as time period. Here this bob we moves from an extreme position and we releases it. If we take this bob into an extreme position here, then we just release it. Then what will happen? It starts to oscillate. This will starts to the oscillation, right? In that oscillation, what all the things are mainly we consider? One is length of the pendulum. So first one is length of the pendulum. What is the length of the pendulum? The length between the point of suspension to the center of the bob is considered as the length of the pendulum. So first one is length of the pendulum. Okay, how this length of the pendulum affects the time period, whether it affect or not. Okay, time period and the length, how they are relating. Here you can see we are taking two pendulum of same bob and everything will be same, but one difference is there. What is that? They are in different length. We are taking two pendulum of different length. One is shorter and the other one is longer. Okay, then we releases both the pendulum together from an extreme position. Then it starts to oscillate. Now you closely watch how they are oscillating. Means both the pendulum begins oscillation together. Now both the cases, is it same way they are oscillating? No, because shorter one it's oscillate faster than longer one. Is it right? So for completing one oscillation, shorter one took very less time and longer one needs more time to complete one oscillation compared to the shorter one. So we can say that length of the pendulum is directly depending the time period. Why? Because length increasing time for one oscillation also will increases, and length decreasing time for one oscillation also will decreases. So this way the length of the pendulum depend the time period. How this time period is depends the length of the pendulum. When the length of the pendulum increasing time period also will increase. When the length of the pendulum decreasing time period also will decreases. Are you clear? So that's all about first case. So we can say that length of the pendulum and time periods are closely related each other. Length increasing time period also will increases. And the second one we consider about mass of the bob. Mass of the bob. What is mass? That means weight. Normally we can consider as, I told you that this bob is made up of metallic board. Okay, and in the second case what we have to take? We are taking two pendulum, and in that pendulum length of the two pendulum will be same, but difference is only about the mass. One is with a smaller mass and the other one is bigger one. Now you can see here we have two pendulum of same length and different mass, and we are taking both the pendulum in same extreme position and we releases it at the same time. Then what happens? They are oscillating. Is while looking this you can see that both the pendulum oscillating in a same way, right? Same speed, or that time for taking one oscillation is same for both the pendulum. Is it right? So this mass of the bob does not depends the time period of a simple pendulum. If we are using the mass different bob, means if we are using the two bob of different mass, then also that time period will be the same. There will not be any change. Okay, and third one we can see that length and mass. So third case is amplitude of the pendulum. Third one is we can consider as amplitude of the pendulum. What is amplitude of the pendulum, or what do you mean by amplitude? Amplitude is the maximum displacement of the bob from either side, or that displacement of the bob. That means if we are consider one of the bob we are taking from this side to start oscillating and the other one we are taking another position. So here you can see that we are taking in for doing this third factor, or finding this third amplitude, how it affects the time period. We are taking two pendulum of same length and we are using the same bob. That means the two of the pendulum with the same length, and the bob also, mass of the bob also will be the same. But what is the difference in that case? We allow both the bobs to releases from a different position. One will be nearby the mean position and the other one is little bit away from the mean position. Okay, different position we releases. One we are taking from this side and the other one we are taking another side in this. So that time what will happen, there also you can see that both the cases that oscillation is similar. So time period for that oscillation also will be the same, both the cases. If we are taking or releases the bow from different angles or different position, then also this time period will be the same. There is no change. Okay, so we can say that out of these three cases, in length you remember one more thing, gravity is also depending the time period of a simple pendulum. Gravity, that is according to your syllabus it is not given, but you just remember gravity is also one of the affecting factor of time period. But in our case, according to our syllabus, we have these three factors: length of the pendulum, mass of the bob, amplitude of the pendulum. Out of these three terms, only this length of the pendulum depends the time period, or time period is depending the length of the pendulum. Okay, this time period does not depends mass and amplitude of the pendulum, it actually depends the length of the pendulum. Time period depends the length of the pendulum. That means length increasing time, time period also will increase. Length decreasing time, time period also will decrease. So these are direct proportion. Directly they are proportional or depending. Length increasing time, time period also will increase. Length decreasing time, time period also will decrease. And one more thing you remember, if we need to find out the time period of a simple pendulum, we can't able to measure one oscillation only, because one oscillation it will be like decimal number, like 1.2 or like that things. So it is better normally by experimental purpose we are counting some more oscillation, then we dividing it. I will show you how we are doing it, or we will explain it with the help of an problem. Okay, we can explain one problem from your textbook, this time period. Okay, from your textbook you can see one example. That means example 1, a simple pendulum takes 32 seconds to complete 20 oscillation. A simple pendulum takes 32 seconds to complete 20 oscillation. What is the time period of the pendulum? So we have to find out time period. That means time for 20 oscillation, in this question itself it is given 32 seconds. So time for 20 oscillation is equal to 32 seconds. Okay, then what we need to find out? Time for, we have to find out time period. Okay, and time period is equal to, time period is denoted by the letter, capital letter T. Then time period T is equal to time for one oscillation. Is it right? Time, we have to find out time period, calculate the time period only our question, and time period T is equal to time for 20 oscillation is not considered as a time period. Time period is time for one oscillation. From this, how can we find out time for one oscillation? In mathematics, you already learnt like that kind of problem. If we can, means we just dividing it. So time for one oscillation is equal to 32 seconds divided by 20. right? In this 32 and 20 we have to solve it by, we knows that both the cases 20 it will become 10 and here 1 16, then while cutting it we will get 16 8 and here it will become 5. 8 divided by 5 it is equal to 1.6 seconds. 1.6 seconds. So here you will get the answer like 1.6 seconds. Then our answer, it is not 5, it is a second. Okay, so the unit is, so the time period of that pendulum is 1.6. This 1.6 by using a stopwatch means like this decimal numbers, it will be quite difficult to find out, but if we are counting more number of oscillation, then in this way we can find out the answer. Are you clear? That means time for 20 oscillation 32 seconds, then time for 1 oscillation 32 divided by 20, then you will get the answer what? 1.6 seconds. Okay, so that's all about the time period and the terms related to time period. Okay, are you clear about it? Now we can go to the next term, that is latest trends in the measurement of time. Latest trend in the measurement of time. That means we already learned that nowadays we are using clock or watch for measuring the time and like that things. So now we also knows that what are the trends or latest trends in the measurement of time. We know basic thing you just remember watch and the clock, but here, so what we can consider, the first thing is pendulum clock. You all you all knows about pendulum clock. Here you can see the picture of a pendulum clock. In this pendulum clock is actually the principle of simple pendulum is used in pendulum clocks. In the, we knows that if we consider a clock, it means it has some arms or hands like minute arm, hour arm, second arm. These arms are moving or hands are moving. How it's moving? That in the case of an pendulum clock, what will happen? This oscillation of the pendulum control the movement of minute arm, second arm and hour arm. Oscillation of the pendulum control the movement of the arms or hands of the clock. Okay, in pendulum clocks. And you all knows about mechanical wristwatch, right? In the case of wristwatch, that balance wheel is there. It has a balance wheel like a pendulum clock. Pendulum, how this pendulum control the movement, the same way in wristwatch this balance wheel control the movement of arms or that hands of the watch. And that's all about wristwatch. In wristwatch balance will control the movement, and quartz watches and clocks are available. Means normally mainly we are using this quartz watch or clock. In the case of quartz watch, having a unique property of oscillating when an electric current is passes through it. That means we are using cells, electric cells, and in this quartz watches it contains or clocks contain quartz crystal. This quartz crystal and these electric cells are creating like an electric circuit inside it, and this circuit produces an electric current. That electric current controls the movement of the hands of the watch or clock. Then we consider about stopwatch. Okay, if we consider a stopwatch, when we discussed about the oscillation of the simple pendulum, I told you that when we are releasing the bob, at the same time when we are counting for finding the time period, we are using the stopwatch. Okay, when we are starts to oscillate the when we are taking the bobs from one extreme position, when we are releasing at the same time, we have to start the stopwatch. Then we count for 20 oscillation, and the end of 20 oscillation we have to stop the stopwatch. Then we will get the time for 20 oscillation. Like previous example, you can see that 32 seconds. Like that only we measured it. And in this stopwatch, it have an push button. When an event start, normally sports meet and all, we can use this kind of stopwatch, because if it is 100 meter or 20 meter, means 200 meter race or any kinds of sports events, when we start the race or start the event, at the time we can these kinds of stopwatch, digital stopwatch, it contains some push button. When we press the push button, then what will happen, it measure the time for that particular event. So in that way we can measure with the help of a stopwatch. And atomic clocks also there, it measure or its movement according to the vibration of atoms. Then timer is another thing that we knows that in our home, washing machines, air conditioners, all it contains timers. In washing machine, like some timers will be there for its working. So this timer speciality is that to record a sequence of events. Okay, so that's all about the latest trend in the measurement of time. First we learn about pendulum clock, right? Pendulum clock, it is based on the principle of simple pendulum, and this oscillation of the pendulum control the hands of the pendulum clock. And we learns about wristwatch. It has an balance wheel, and the movement of this that balance wheel oscillation, or that balance wheel control the movement of the hands of the watch. Then quartz watches and clocks, it having an quartz crystal and cells, it creates an electric circuit. Through this electric circuit, a small electric current is passes through it. That electric current control the movement of the arms. Then stopwatch, timer and atomic clock. So that's all about latest trends in the measurement of time. Now we are discussing unit of time. Unit of time. What is the unit of time? That means whenever we are discussing an unit, that unit, it having a standard unit, SI unit. In the last year we already discussed about SI unit of different kinds of physical quantities like length, distance, that all the things we learn. Even time also we learn. So the standard, or what is the SI unit of time? The SI unit of time is second. SI unit of time is second, and the SI unit of time we can consider as second, and it is denoted by the letter small letter. Yes, it is denoted by a letter small letter S. Okay, small letter S. Then that's a small letter S, and this second is the standard unit of time, and at the same time it is a small unit, right? And sometimes we need to express the time in higher unit. This higher unit are hour, minutes, these all we can consider as a higher unit of time, and we can relating or different case the units of time, the relationship we can tell. Okay, now we can discuss. We knows that 60 seconds is equal to 1 minute. This M is minute, and 60 minute is equal to 1 hour. 60 minute is equal to 1 hour, and 24 hour is equal to 1 day, right? 24 hours is equal to 1 day and 30 days is equal to 1 month and 12 months is equal to 1 year. Then 10 years is equal to 1 decade and 100 year is equal to 1 century and 1000 year is equal to 1 millennium. That's also given in your textbook. Just read it. These are the different units of time, but the standard unit of time is second, or SI unit of time is second. These are various unit. Anyhow, the standard unit of time is second. SI unit of time is second. Okay, so that's all about the things related to time. So our chapter name is time and motion. This time we almost finished. That means the main content regarding the time over. That means in the case of time we learns about how the ancient people measure the time, and we discussed it on the basis of simple pendulum. Then we learns about the latest trend in the measurement of time, then unit of time. So that's all about time, and now we can go to, or we can discuss motion. Okay, this motion means that, or when we are looking around us, you can see that different kinds of objects are, some are moving, flying of birds, moving of vehicles and flying bird. Then if any like that, many kinds of movements you can see, right? And at the same time you can see that when you are looking you just imagine your classroom. In a classroom you can see desk, bench, chairs, table, like that things are present. All these things are moving or not? No, it's at the state of rest. Okay, then what is motion and rest? Its definition. Rest means that an object, for example in our classroom, if this table is not changing its position, okay, so table we can consider as an object. Okay, so an object does not change its position with time and with respect to its surrounding. Surrounding means the around, means surrounding part of the table. An object does not change its position with the time and with respect to the surrounding is considered as rest. Okay, motion means that an object which changes its position with the time and with respect to its surrounding is considered as motion. Okay, rest and motion. Motion means that an object changes its position with the time and with respect to its surrounding is considered as motion. For example, if you if you are sitting inside a classroom, so you all have your own seats. Okay, if the teachers are taking the class, you all are sitting in your own seat. When the bell ring, then what will happen? You all will coming out of your class. So that time when the teacher is taking the class, you are in a state of rest. You are sitting in your own seat, and when the bell ring, then what will happen? You will move from your class to any other, means you will go outside. So that time you are changing in your class, you can see normally we knows that some walls will be there, these walls and the person sitting next you, that all the things are your surrounding factors. Okay, when the bell ring, then you will go out. Okay, so that time you are going away from your class, you are moving away from these four walls and everything. So that time you are in a state of motion. Okay, that's all about this motion. And we already knows that there are different types of motion, like That also we learn rectilinear motion, periodic motion, non-periodic motion and oscillatory motion. Like this different types of motion we learn, right? And in these different types of motion, example also we learned in previous class. And here you can see in your textbook some kinds of motion. Here it is given. First one, a car moving in a straight line. Which kind of motion it will be? An object which moves in a straight line, it is termed as, yes, rectilinear motion. Rectilinear motion, a car moving in a straight line. Then a spinning top. Which kind of motion will be? Rotatory motion, spinning top. It's moving from a fixed axis, so it is a rotatory motion. And moving blades of a fan. Moving blades of a fan. It's also like same rotatory motion. You can write there rotatory motion. Then last one, pendulum of a clock. Pendulum of a clock. Oscillatory motion, that already we discussed, right, in the case of simple pendulum. So these are the different types of motion. Okay, and you find some more motion and which type of motion it is, like that you just find it. And next topic is slow and fast motion. Next topic is slow motion and fast motion. Okay, this we can explain with an example. Okay, if you consider that normally from your home to our school, that distance is 3 km. You just imagine the distance from your home to school 3 km. Okay, and usually you are coming to the school with your bicycle. Okay, and that time it takes 20 minutes. Just you imagine, it's like an example. So that means from the school to from home to your school distance, home to school distance is 3 km. Okay, usually you are coming in bicycle, and with bicycle you are coming to the school, and when you are coming with a bicycle, it took almost 15 minutes or 20 minutes, we can consider 20 minutes, just for an example. Okay, then one day you means because of your exam or like that, you have to reach at school early or some or other reason, or that time it takes for bicycle, it mainly take 20 minutes. And okay, school bus is also going in front of your house. So one day you decided to come in this school bus. Okay, so that time bus take only 5 minutes or 7 minutes, 7 or 5 minutes to reach the school. Okay, so you just see both the cases, from your home to school it is only 3 km distance. By bicycle it's take 20 or 15 minutes time, but by bus within 7 minutes you reach the school. Okay, so both the cases distance same, but time is different. This is slow and fast motion. That means if we need to, or if we consider that an object took longer time to complete a certain distance, is considered as slow motion. An object is what? Bicycle took longer time to cover certain distance is termed as slow motion. And bus, an object or bus takes shorter time or short time to cover the same distance is termed as fast motion is termed as fast motion. Okay, these are slow motion and fast motion. Slow motion means that an object takes longer time to cover a certain distance is considered as slow motion, and fast motion means that an object takes short time to complete the same distance is considered as fast motion. Okay, so that's all about today's class, and today we discussed about the various factors which affects the time periods and the latest trends in the measurement of time. Then we learns about unit of time, motion, rest and slow motion and fast motion. Okay, so you just learn all the definitions and everything. Next class we can continue, and now we can wind up our class. Thank you.